7, we have a uniform electric field that's collapsing. The vertical scale is set by 6 times 10 to the 5th Newton per Coulomb, so this is actually 6 over here. And the horizontal axis is up to 12 microseconds over here. Calculate the magnitude of the displacement current through a 1.6 square meter area perpendicular to the field during each of the time intervals shown. Ignore the behavior at the ends of the intervals. So, what we've got here is an interesting situation. Again, a quick reminder, displacement current is epsilon naught times the change in electric flux over time. But in this case, since I have a graph of electric field versus time, I'm going to isolate that out and rewrite flux as area, which is constant, that's this number right here, times dE dt, which you should recognize is just the slope of this graph. So for segment A, I just need to find the slope of the graph from here to here. How do you find the slope? Well, it's just rise over run. In this case, final minus initial. If this is 6 up here, this must be 4. This must be 2. And so in this case, it goes from 6 to 4. And the time interval, let me put a few units in here as well. This would be 4. This would be 8 microseconds. And so the time interval is just 4 microseconds, which I'm writing as 10 to the minus 6th. If you go ahead and solve that just by plugging in numbers, you'll calculate the voltage during this time. And again, it's technically negative, but they're interested only in the magnitude, is 0.708 volts to 3 sig figs. For segment B, it's kind of interesting. As you can probably tell right here, the slope of the graph, dE dt, is going to be 0. In this case, there is no change in the rise, the vertical, over the change in time. And so the voltage is simply 0 volts. But then finally in segment C, we've got the slope over here. It's a fairly large slope, which is going to produce our greatest dE dt in any of these segments. Plugging in the numbers, we go from 4 down to 0. And our time interval is, this is roughly 10 microseconds right here. So from 12 to 10 microseconds. And that slope then gives us a voltage of 2.83 2.83 volts. Hopefully this makes some sense. In this case, you're analyzing the slope of this graph to calculate these. Good luck!